Welcome to the second lesson of sequences. Hopefully you have already watched the first lesson because that will be very, very useful for leading into what we'll be looking at today. And I hope that you managed to have a go at these starter questions. As always, we'll start by going through these questions. We'll focus in on the top left box first, where I asked you, what's a linear sequence? So last lesson we looked at the definition of a linear sequence, and hopefully you wrote down a linear sequence is a sequence that increases or decreases by the same amount each time. Yeah, or I think I said in the lesson goes up or down. So it increases or decreases by the same amount each time. So for example, 1, 2, 3, 4, 5, our basic number series or sequence, just counting up by 1, that is a linear sequence because you are increasing by 1 each time. 2, 4, 6, 8, you're increasing by 2 each time. And there are an infinite amount of linear sequences. And then I've asked you, what is the nth term? So this is something that we looked at quite in detail last lesson. And you should have wrote down that the nth term is an expression, and that just means something that has different terms in there, for example n. So it's an expression that can be used to find any term in a sequence. Okay, so is it an expression in terms of n, because it's called the nth term, that can find any term in the sequence? And we'll get to look at that now. So we're going to look at both of these things, what is a linear sequence and what is the nth term, in these three other starter questions. And this is what last lesson looked at. So generate the first 5 terms of 4n plus 2. Well, what is this saying? This here, 4n plus 2, is what we refer to as the nth term. Okay, this is the nth term. This is going to let us find any term in the sequence. And for this question, we want the first 5 terms. Okay. Well, if I want the first term, recall that if I want the first term, we say that n is 1. Because you have to understand that n, in the nth term, n represents any term in the sequence. So if you want the first term, n is 1. If you want the second term, n is 2. If you want the third term, n is 3, etc. So for the first 5 terms, we will be looking at when n is 1, 2, 3, 4, and 5. But we also looked at other ways where we can speed up the process when going from term to term. So how do I get the first term? Well, if n is the term I'm looking for the first term I'm looking for n is 1, all I've got to do is substitute n for 1. So I'm going to say this is n as 1, so that's 4 times 1 plus 2. And remember, 4n means 4 times n. So 4 times 1 is 4, plus 2 would be 6. So the first term would be 6. For the second term, you simply do the same but replace n as 2. So n is 2, so that would be 4 times 2 plus 2. 4 times 2 is 8, plus 2 is 10. For the third term, you do the same. You replace n with 3 because for the third term, n is 3. And it's really straightforward, but you have to have a very clear understanding of that. So 4 times 3 would be 12, plus the 2 would be 14. And what we discussed last lesson, and you can probably see a pattern here, what's happening to our sequence? It's going up, from 6 to 10 is going up by 4, and from 10 to 14 is going up by 4. So we would say this is a linear sequence because we can see it starting to go up by the same amount. And last lesson we made the link that, and we wrote it down, whatever is in front of the n, in this case 4, is what the sequence is going up by. So if you understand that clearly, I now know that to get the next term, I can see that in front of n is 4, I can simply, instead of putting n is 4 in, I could simply realise, well, it's going to be going up by 4. So I could just add 4. So 14 add 4 would be 18. And we can check, would we get the same answer using our first method? Well, if n is 4, 4 times 4 is 16, plus 2 is 18. So you would get the right answer. So the quickest way to find a term-by-term sequence is once you've found the first term, spot what the term is going up by, which is in front of n, in this case 4, and just add 4 each time. So if I add 4 now, I would get 22. So we can take that understanding now to help us answer these questions a little bit quicker than having to substitute in every time. Rather than having to change n for 2, 3, 4 and 5, we could simply find the first term, realise it's going up by 4 and add 4 each time. So let's see how that would work on question number 3. Generate the first 5 terms of 6n minus 5. So the first thing that we should realise is that is the nth term. They've given us the nth term here, 6n minus 5. And I want to find the first 5 terms. Well, the most important one we need to find is the first term where n is 1. So if we replace n as 1 in, we would have 6 times 1, which is 6, minus 5 is 1. So the first term in this sequence would be 1. Again, because I'm replacing n with 1, 6 times 1 is 6, minus 5 is 1. Well, instead of having to now do that for n is 2, n is 3, n is 4, n is 5, I can simply see what is in front of my n, 6. This tells me, from what we learnt last lesson, this sequence is going up by 6. A lot of students get mistaken and think that it's going down by 5 because they see this minus 5 here. That is a common mistake. It is not going down by 5. What determines whether the sequence is changing up or down is what is in front of the n. And in this case, it is 6. So if I add 6 to 1, I would get 7. If I add 6 to 7, I would get 14. No, I wouldn't. I'd get 13. Sorry. And we can just repeat that. We can just keep adding 6. Alternatively, if I wanted the fourth term, I could say n is 4. 6 times 4 is 24, minus 5 would be 19. However, much easier would be just to add 6 onto 13, which is 19. So you get the same answer. And as you can see, once you realise what the term is going up by, it's a lot easier just to add on 6. So to get the fifth term, I could just add 6 onto 19, which would be 25. Alternatively, you could do 6 times the fifth term, 5, minus 5. 6 times 5 is 30, take away 5 is 25, get the same answer. But as you can see, it's a lot easier just to add 6. And again, be very clear that this only works when you are doing term by term sequences. When you're going from like the first term to the second term to the third term, you can use the trick by adding on, not really a trick, the actual method of an understanding of what's happening to the sequence by just, in this case, adding on 6. Okay, and that takes us on to this last one, where we looked at an example of this. And now we're going to see when we can't use that method of what is in front of the n is what is changing by. Because this is what we call a non-linear sequence. The two examples we've just done were linear, they were going up by the same amount. However, this is a non-linear sequence. And I know it's a non-linear sequence because it is n squared. This squared means that it is non-linear. Now, as you can see, these two here, 4n plus 2 and 6n minus 5, I know are linear because they are not squared, they are just n. If it is just n, they are linear. If it is n squared, they are non-linear. So here we have to go through the first method I showed you where you take n for 1, 2, 3, 4 and 5 and substitute it in. So what do I mean by that? Well, if I want the first term, I'm going to do n equals 1. And then I'm going to replace n with 1. So 1 squared is 1 plus 7 is 8. 1 squared is 1 plus 7 is 8. Now I'm going to replace n for 2 because I want the second term. So that means 2 squared. And remember, squared means times it by itself. 2 squared is 4 plus 7. 4 plus 7 would be 11. So the second term is 11. For the third term, n is 3. Okay, so if I replace 3 in, I'm going to do 3 because n is 3 squared. Okay, 3 squared plus the 7. So what is 3 squared? 3 squared is 9. 9 plus 7 would give us 16. And we're going to have to do that for the fourth term. So when n is 4, 4 squared plus 7. Well, what is 4 squared? 4 times 4 is 16. And 16 plus 7 would give us 23. So the fourth term is 23. And exactly the same for the fifth term. When n is 5, I look at my nth term and I'm going to replace n with 5. So I'm going to do 5 squared plus 7. Well, what is 5 squared? 5 squared is 25. 5 times 5 is 25. Plus the 7 would give us 32. So this will now confirm what I just said at the beginning. Is this sequence linear? Well, let's check what it is increasing by. Between 8 and 11, it's going up by 3. By 11 and 16, it's going up by 5. By 16 and 23, it's going up by 7. And by 23 and 32, it's going up by, what's that going up by? 9. Okay. So as you can see, is this linear? No, it's not going up by the same amount. And I know it's not linear because it's n squared. And I know the other two are linear because it is just n. It's just 4n, 6n. There's no squared. Okay. So, when can you use the just add on or take away what it's going up by? Only on non-linear sequences where it is just n, 4n, 6n, minus 2n. It doesn't work for the squared. You have to do the substitution method where you take n is 1, 2, 3, 4 and 5 and substitute it in. Okay? So, that leads us very nicely onto today's lesson, which will be looking at how do we find the nth term. So what we saw in the starter, what we saw in the previous lesson was how do you get the nth term and make a sequence. Okay, how do you generate, how do you create a sequence? What we're going to look at now is how do you be given a sequence and find the nth term. So what do I mean by that? I simply mean, let's just pretend I gave you this sequence here, 6, 10, 14, 18 and 22, and I didn't tell you that the nth term was 4n plus 2. And I wanted you to tell me that the nth term is 4n plus 2. How would you do that? Well, this relies heavily on the understanding that we've looked at last lesson, what we've looked at just a second ago. Knowing what the sequence is going up by, or down by, because sometimes they increase, sometimes they decrease, is really important. So if we take this sequence, 6 to 10 to 14 to 18 to 22, I have to first realise this sequence is going up by 4. Yes, plus 4. Well, we've discussed whatever the sequence is going up or down by is always in front of the n. So I would write 4n. So then the question is, how do I work out what this bit on the end is, like the plus 2, the minus 6, whatever the extra bit of the nth term is? How do I get that? Well, you do that by, once you've realised, and I'll go in depth about this in a minute on the example on the next page, but once you realise the sequence is going up by 4, I write 4n. Well, that means the first term would be 4 times 1, which is 4. But as you can see, my first term is not 4. It's actually 6. How do I get from 4 to 6? I add on 2. So that is where this plus 2 has come from. Okay. And if you didn't quite get that right now, we're going to really break it down with this first sequence that I've written for you here, finding the nth term. I've given you a sequence here that says 4, 7, 10, 13. And we want to find the nth term. So we want like something that says something like 3n plus 2. Yeah, it might not be that, it probably isn't that, but we want to work out what is the nth term. So the first thing that we need to do is realize, what is this sequence going up or down by? Well, let's check. 4 to 7 is plus 3. 7 to 10 is plus 3. And as you can see, 10 to 13 plus 3. It's a linear sequence, yeah? It's a linear sequence because it's going up by the same amount every time. And we know, don't we, that if it's going up by 3, the nth term, whatever is going up by is in front of the n. So I could write 3n. Okay, so the first part of my nth term is 3n because it's going up by 3, so I write 3n. Now I need to check, what is this bit on the end going to be? Is it going to be plus 1, minus 2, plus 8? How are we going to work that out? Well, we're going to focus on the first term. If it is going up by 3, and n is the term we're looking for, if we focus on the first term, what would 3 times 1 be? Because for the first term, remember, n is 1. 3 times 1 would be 3. So what I'm just going to do, and the trick here really is, that's all you need to know. Whatever it's going up by or down by, you simply write above the first term. So it's going up by 3, so I'm going to write 3 above the first term. And then you've got to ask yourself, my first term is 4, but at the moment I've got 3. How do I get from 3 to 4? How do I get from here to here? I would add 1. Hopefully you can see that it would be plus 1. So my nth term would be 3n plus 1. Okay? And you can check, the best thing about these questions are, once you've made an nth term, we can use our understanding that we've already got to check if we're correct. Pick any other term in the sequence. You can pick any of these terms and check. Let's just say we're going to check with this term here, 10. What term is 10? Well, first term, second term. 10 is the third term. And remember, for the third term, n would be 3. So we can check. We're looking at the third term. What is 3 times 3? 9. 9 plus 1 is 10. And our third term is in fact 10. Therefore it works. And you can check if it works for the next term. This is the fourth term. So let's replace n with 4. 3 times 4 plus 1. Well, what is 3 times 4? 12. What is 12 plus 1? 13. And as you can see, the fourth term is in fact 13. Which means we've got it correct. Which means this nth term that we found is working for all of the terms that we've got in the sequence. So then I could ask you, what would the 50th term of this sequence be? What would the 50th term be? Well, a really bad method would be to add 3 on 50 times until you get to the 50th term. That would be a terrible method. But what do we know? If I want the 50th term, n is 50. So I could do 3 times 50 plus 1. 3 times 50 is 150 plus 1 would be 150. So for the 50th term in the sequence, which would be somewhere right the way down there, if I carried it on, the 50th term would be 150. And that's why the nth term is so powerful. You can work out any term in the sequence without having to add 3 on every time in this case. You could just be like, right, the 100th term, that would be 3 times 100. 300 plus 1 would be 301. So the 100th term, which would be way down there, would be 301. So let's turn what we've just discussed into some steps. Yeah. So when you look back at this, you can see, step 1, do this, step 2, do that. Step 1, what did we do? We found what the sequence is increasing or decreasing by. Okay, we found what the term, or what the sequence, sorry, is increasing or decreasing by. That was the first thing we found. And in this case, it was 3. Yeah, we realised, it's going up by 3. Okay. What was step 2? Step 2 was you write what the sequence is changing by in front of n. Yeah? So, and let's just refer back to this. Yeah? Well, maybe we'll number it. We can number this. This was step 1, finding out that it was going up by 3. What was step 2? Once we found out it was going up by 3, we wrote it in front of n. So this bit here is step 2. Step 3, remember, whatever the sequence was going up by, we wrote above the first term and checked the difference. So you write the sequence change above term 1. Okay, write the sequence change above term 1 and find the difference. Okay, so that bit there was step 3. Okay, that bit there was step 3. So just to recap, you find the difference, you write that in front of n, so 3n, then you take what the difference is, 3, you write it above the first term, and then you check how do you get from 3 to 4. What's the difference between 3 and 4? It's plus 1. Okay, so going into example 1 then, let's see if we can take this understanding and all of these steps and start to transfer it onto different types of questions. So example 1, we've got a sequence that says 2, 4, 6, 8, 10, and we want to find the nth term. So step 1, let's check the difference. What is this sequence going up by? Plus 2, plus 2, plus 2. So we can write 2n. Yeah, step 2 says whatever the sequence is changing by, right in front of n. So it's changing by 2 plus 2, so it's 2n. Then what you do is you take what it's changing by and you write it above the first term. So remember, this is the first term. So we're going to write 2 above that. Well, as you can see, 2 is already the first term. So what would the difference be? Nothing. We don't need anything. We don't need a plus or minus anything. You could put plus 0, but that'd be pointless. What would be the point of writing plus 0? So the nth term for this is simply 2n. Because we can check if it works. What term is this? This 10 is the first, second, third, fourth, fifth term. So for the fifth term, remember, n is 5. What would 2 times 5 be? 10, which is correct. So we don't need any extra step for this one. Simply, there was no difference between 2 and 2, so it is just 2n. For example 2, find the nth term of 4, 9, 14, 19, and 20. Well, what is this sequence changing by? That is the first step. Hopefully you can see that this sequence is going up by 5 each time. So if it is changing by 5 each time, we can simply write 5n. Because whatever it's changing by, you write in front of n. Now we can check. Let's write the 5, what is changing by above the first term, and see what the difference is. So this is the question you need to ask yourself. How do I get from 5 to 4? Yeah, a lot of students here would do it the other way, but it's how do I get from what I've written above to the actual first term? How do I get from 5 to 4? Well, clearly I need to minus 1. Okay, to get from 5 to 4, I need to minus 1. Not plus 1, minus 1. So the answer to this would be 5n minus 1. And you can check if it works. Let's take this term. This 20, what term's that? It's the first, second, third, fourth, fifth term. So 5 times 5 is 25. I don't know why there's 20 there actually. I've just found a mistake in my own workings. What should that be? If this sequence is going up by 5, it shouldn't be 20. It should be 24. So you might just want to change that to 24. And I'll highlight what I've changed. So I've found a mistake in my own sequence. That sequence wasn't linear because the 20 should have been 24. Let's check now. 5 times 5 is 25, minus 1 is 24. So that's correct. Check it for this one, the fourth term. 5 times 4 is 20, minus 1 is 19. So it works. So definitely make sure you change that 20 to 24. That was just me being careless when making the sequence. But as you can see, the nth term works for the sequence. Example 3. Find the nth term of 7, 5, 3, 1, and minus 1. First step, what is this sequence going up or down by? 7 to 5 is minus 2. 5 to 3 is minus 2. 3 to 1 is minus 2. 1 to minus 1 is minus 2. So this sequence is linear. Yeah, this one's actually linear. It's going down by the same amount. So whatever it's going up or down by, in this case minus 2, gets written in front of n. So we write minus 2n. Then you take what is it going up or down by and you write it above the n, or the first term. So that would be minus 2 would go above the first term. Then you check, how do I get from minus 2 to 7? How do I get from minus 2 to 7? Well, if I'm at minus 2 on a number line, and I need to get all the way up to 7, hopefully you can see that it's going to be plus 9. It gets you to plus 9. Okay. I need to add 9 to minus 2 to get to 7. So the answer to this is minus 2n plus 9. Okay, and we can check. We can check if that works. Let's pick any term in the sequence. Let's pick this 3. It's the first, second, third term. So if we're checking the third term, we would put minus 2 times 3 plus 9. Well, what is minus 2 times 3? Minus 6. And what is minus 6 plus 9? If you're at minus 6 and you add on 9, it does in fact get you to 3, which is our third term. So the nth term works. It works for more than just the first term. Okay, so that would be it. And then you can use the nth term again to find any term in the sequence. If you wanted the 10th term, you would do minus 2 times 10 plus 9. Minus 2 times 10 would be minus 20, and minus 20 plus 9 would be minus 11. Okay, so it'd be minus 11. Now, for these negative differences, you have to be good at your positive and negative numbers. You have to be able to add and subtract negative numbers. And if you find it difficult, think of a number line. Either think of a number line across, some of you think of a number line down, but think of a number line and think, how am I going to get from there to there? That would be the easiest way to do it. Okay. The only bit that students find difficult about this is the negative and positive numbers. Okay. So that takes us on to example number 4. So let's check here. The first thing we check, find the nth term of minus a half, 0, a half, 1, 1.5. The first thing we're going to check is what is happening to the sequence. What is the rule, what is the term by term rule of the sequence, okay? Well, how do I get from minus a half to 0, and 0 to a half, and a half to 1? Well, hopefully you can see you're adding a half each time. You're adding on 0.5 each time. Okay? So if I'm adding on 0.5 each time, that would be 0.5 n. A half n. You write that above the first term, 0.5, and you ask yourself, how do I get from 0.5 to minus 0.5? Well, if you think of a number line, 0's there. If I'm at a half, 0.5, and I want to get to minus 0.5, what do? I take away 1. And hopefully you can see that. I have to take away 1. So to finish off our nth term, it is going to be a half n, 0.5 n, minus 1. Okay, minus 1. Another way you could write that, remember, is a half n minus 1. So they are both the same. They're just written, one's written with a half as a decimal and one's written with a half as a fraction. So, the only difficult part of this is the last part where sometimes you have to think about a number line and negative and positive numbers. Just be really careful. And the beauty of these questions is you can check. Once you've made an nth term, pick any other term in the sequence and check it. Okay? So, now I've got some practice questions for you, where I want you to replicate those methods that we've been looking at. So the first thing I want you to do, and you can start now, and if you're watching on playback you can pause, and then I'll go through the answers. But find the difference. Write that in front of n. Write the difference above the first term, find that difference, and that would get you your nth term. So I'll give you a little bit of time to get a start on those. And then what I'll do is I'll just write the answers for the first couple, and then when it starts to get a little bit harder, I'll start to talk about the solutions. So hopefully you managed to get 3n plus 2 and 3n plus 1 for the first two. Again, because the difference is plus 3, so 3n, you write 3 above the first term. How do you get from 3 to 5? You add 2, so 3n plus 2. Same for the second one, 3n, it's going up by 3. How do you get from 3 to 4? You add 1. On the next one, it's going to be 3n again, but as you can see, when I write 3 above the first term already is 3, so I don't have to do anything. I don't have to add anything. I'm already at 3, I'm where I need to be, so you just leave it as 3n. Be a little bit careful on the next one. It's going to be 3n. You write 3 above the first term and ask yourself this question: how do I get from 3 to 0? I have to take away 3, so it's going to be minus 3. 3n minus 3. Same with the next one. Be a little bit careful. Hopefully you straight away, it's going up by 5, 5n. Write 5 above the first term. How do I get from 5 to 0? I must minus 5. Yeah, a lot of students here, they get it wrong because they add 5. Because they see the 0, they see the 5. They're like, oh, the difference is 5. But it's how do you get from the 5 to the 0? Because we want to get to the actual first term. So 5n minus 5. And that will just take us on to some sequences with negatives in them. Okay, so always checking, what is the sequence changing by? This first one is changing by 5. It's going up by 5. So you would write 5n. Then you take 5, write it above the first term. And this is where you just have to be a little bit careful. Ask yourself, how do I get from 5 to minus 2? Well, to get from 5 to minus 2, I have to take away 7. So it would be 5n minus 7. You can always, again, if you're unsure, if you've done a question, you're like, I'm not sure if that's correct. Pick any other term in the sequence. So let's just say this 8. Which term is that? It's the first, second, third term. So replace your n with 3. So 5 times 3 is 15. 15 minus 7 is 8. And 8 is the third term, so I know I've got my nth term correct. So they are self-checkable. So continue with those. And if I'm going a little bit fast for you, you can pause, do them, and then play, see how I'm getting on. So what's this going up by? It's going up by 10. So if it's going up by 10, I can write 10n. Then I can write 10 above the first term, and then ask yourself, how do I get from 10 all the way down to minus 4? I'd have to go down to 0 and then down to minus 4, so it'd be taking away 14. So it'd be 10n minus 14. And then these next three, they look harder because the numbers are bigger, but it's the same principle. What's happening to the sequence? And a little trick here is the first two terms look quite difficult to work out what's going on. But if you just check the second two, how do I get from 60 to 160? Or 160 to 260? I can see that it's plus 100. So you can save yourself a bit of brain power by just moving across and checking the one that looks easier. So this is going up by 100, so it would be 100n. Yeah, even though the numbers are much bigger, same principle. How do you get from 100, because you write that above the first term, all the way down to minus 40? Well, you'd have to take away 100 to get to 0, and then take away another 40 to get to minus 40. So that would be minus 140. Okay, and that's just basic number line stuff. That is usually the bit that students get stuck on or get wrong. But it's just basic number line, thinking about adding and taking away positive and negative numbers. And then the final two will be, that's plus 100 again. So it is going to be 100n. We write 100 above the first term. How do you get from 100 to 60? Well, you'd have to take away 40. Not add 40, because I'm going from 100, remember, to the first term 60, to take away 40. So it'd be 100n minus 40. And then finally, this usually throws students because it's negative. But what's happening to this sequence? We're going from minus 60 to minus 160. So we're going further down, so we're actually taking away. We're taking away what? We're taking away 100. Taking away 100. So this sequence is minus 100n. It's going to be minus 100n. So we write minus 100, remember, above the first term. And we need to check, how do we get, and you just have to be careful here, how do you get from minus 100 to minus 60? Well, if you think of a number line, it's always easier sometimes to visualize it as a number line. If you think of a number line, if you're at minus 100, which is down here, and you want to get to minus 60, well, where is minus 60? It's further up, it's more towards 0. So I need to go back up the number line, which means I need to add. And how do you get from 160? You would add 40. So because we're going back up towards 0, we have to add 40. So that would be plus 40. Okay, so it'd be minus 100n plus 40. And again, you can take any term in the sequence and check, does it work with the nth term that I have made? Okay, so that concludes the lesson on how to find the nth term. Again, 3 simple steps. Find the difference. Write the difference in front of n. Write it above and check the difference of the first term. And that is how you get the bit on the end. Okay. So I will link some additional questions in the description. There will be a sequences 3 and a sequences 4 lesson. The sequences 3 lesson will look at how do you check to see if a number is in a sequence. Okay, so let's just say, if we're looking at this sequence here, how could you check if 20 was in the sequence? Like, is 20 in the sequence? How do you check that without having to add on the difference each time? And then sequences 4 is going to look at those quadratic sequences, so the n squareds. Okay, so have a go at those. Practice the questions that I put in the description. If you've got Hegarty Maths, go on Hegarty and check out the nth term questions. Give those a go. The more practice you can do on these, the easier you'll find it. But hopefully you learned something. Thank you for tuning in, and I will see you in the next one.